Alright, this problem is a solubility problem again, but it is a Q problem because the question is predict whether or not a precipitate will form. Anytime you see will a precipitate form, you're talking Q. So at this point, there are actually a couple ways to work this problem. We're going to work it the first way, and then we'll work it the second way, some of which is the same, some of which is not. Okay? So the first thing is we've got to know what our KSP is. Oh, there it is. So if we're working a Q problem, remember we're looking to see whether magnesium hydroxide will form basically from is there enough magnesium present plus hydroxide present to cause precipitation. So what we're really looking for is the concentration of magnesium first, and then the concentration of sodium hydroxide. Now, how do we do the magnesium? We're going to mix 75.0 mils of sodium hydroxide with this much magnesium chloride. So for our magnesium concentration, it's going to be 125.0 milliliters times 0.018 molar divided by my new volume, which will be 200 milliliters. So my magnesium concentration comes out to be 0.01125 molar. Now my hydroxide ion concentration, on the other hand, we have 75.0 milliliters times I need a concentration. Oh wait, where do I get my concentration? My molar concentration is going to be related to, remember, the pOH. I know that pH plus pOH equals 14, so my pOH is going to be equal to 14 minus 10.58, which is equal to 3.42. So my hydroxide ion concentration is going to be 10 to the negative 3.42, which comes out to be 3.801894 times 10 to the minus 4th molar. All that just to get this. So we're going to put it back in here. 3.801894 times 10 to the minus 4th divided by 200 milliliters. So I have a whopping concentration of 1.425710 times 10 to the minus 4 molar. Alright, so now I've found my magnesium concentration. I need my hydroxide concentration. So I have a Q problem. Q is going to be equal to magnesium, 2 plus, times OH minus squared. Okay, so we're going to plug these values in. So 0.01125 molar times 1.4257 times 10 to the minus 4th molar. Except this one is going to be squared. So when we do this, Q comes out equal to 2.286730887 times 10 to the minus 10th. So then the question is, what is Q relative to K? Well, Q is 10 to the minus 10th, whereas KSP, this is 10 to the minus 10th, this one's 10 to the minus 11th. Which one is smaller? Well, 10 to the minus 11th is smaller, so Q is greater than KSP. So that means a precipitate will form. So, yes. So then the next question says, if yes, what is the pH needed to stop precipitation? If no, what is pH needed to start precipitation? So since our answer is yes, what we're going to need to know is the precipitation stops at what pH? Now, remember, the point at which the change occurs is when KSP is equal to Q. This is where it changes. So if it was yes, it becomes no. If it was no, it becomes yes. Q is equal to KSP means there's solid present, so there was precipitation. So in this case, it's going to stop when we get below that point. Okay? So if that's the case, let's set it up where KSP, which equals Q, is equal to the magnesium concentration times the hydroxide ion concentration squared, which, remember, the hydroxide is what we're really looking for, because this is going to be our X, because this is what dictates pH. So we plug in what we know. If we go back up, we know that we have 0.01125 molar. X squared is equal to my K value, which is 1.8 times 10 to the negative 11. Okay, so if that's the case, then we end up with X squared is less than 1.6 times 10 to the minus 9, which means X is less than 4.0 times 10 to the minus 5th molar hydroxide ion. Well, if we have that hydroxide ion, we take the negative log of 4.0 times 10 to the minus 5, which gives us a pOH equal to 4.398, which means my pH is equal to 9.602. If that is the case, and we need it to stop, then the precipitate will not form if the pH is less than 9.602. So that is where our precipitation stops. So this problem, the hydroxide ion concentration is what's tied into the precipitation, but you don't need to look for it separately. This is the first way to work this problem. I'm going to do a second version of the same problem.